My name is Mayank Vadhavan, and this is my presentation for final project in pattern recognition course. My project is titled Gender Classification using LDA, KNN, SVM, Naive Bayes, and Decision Tree Learning. So the main purpose of my project was to compare performance and accuracies of these classifiers for the purpose of gender classification. The comparison of results of these classifiers are mentioned in detail in the results and analysis section of my final project report. In this project, I have performed gender classification from static images using 5 different classifiers. They are linear discriminant analysis, k nearest neighbors, support vector machines, naive Bayes, and decision tree learning. So the topics which I will cover in this presentation are applications, introduction, dataset, classifications used, running code, existing approaches, results, future improvements, conclusion, and project demonstration. So gender classification has many applications, like it can be used for targeted advertisements for men and women. It can also be used in video games to create new avatars. It can also be used in statistics. So gender classification in my project is done on images only. So initially, the first phase is the learning phase. So I read around 312 images from the folder. I convert them into gray. Then I apply Gaussian filter and HOG features are extracted. So over here, you can see how the HOG features are extracted. I'll show you in detail in the project demonstration how this is done. So the data is then fed into 5 different classifiers, which are LDA, KNN, SVM, naive Bayes, and decision tree learning. So the next step would be prediction. So the same steps would be followed for the text test image. So initially, test image is fed from the gallery. It is converted into gray. Then Gaussian filter is applied. HOG features are extracted. It is sent to classifiers for prediction. So the results are verified by comparing the actual label with the predicted label. So uh, I got my data set from the FEI face database. So in my data set, there are 156 images for male and female respectively for training images, and there are 40 uh, images for male and female respectively for testing. And so the total number of images come down to 196 and 196. So the total would be 196 plus 196. So I have used these 5 classifiers: LDA, naive Bayes, KNN, SVM, and decision tree learning for the purpose of gender classification. I have done gender classification for each of these classifiers, then I've compared the results. I'll show you in the results and analysis section later on. So the first classifier which I've used is linear discriminant analysis. So LDA is used to reduce the dimension of the data into lower dimension. So this helps in reducing the CPU cost and the memory usage also. The new feature space will have better class label separation. So over here you can see for LDA, the class separation is very good as compared to PCA, which is principal component analysis. LDA is a supervised algorithm because it takes into consideration the class labels of the data. So LDA is more suitable for classification algorithms, whereas PCA is an unsupervised algorithm. So naive Bayes algorithm is very simple. It is a probabilistic classifier and it uses Bayes theorem. I have discussed the naive Bayes algorithm in detail in my final project report, how it is done. Now I'll discuss k nearest neighbors. So KNN algorithm has 2 steps. First one is training phase, in which I store the data in the class label. Algorithm is given 2 inputs, which is the value of k and the new data to be classified. Then we find out the k closest neighbors of the new data. So how the new data is given a class label. So whatever class label has the maximum occurrences among the k closest neighbor, so that one is the new class label of the new data. So this is an example for KNN algorithm. In this example, the value of k is equal to 3, and the new data to be classified is there in the black over here. So in this case, the 3 closest neighbor, out of 3 closest neighbors, 2 are red and 1 is blue. So on the right side, you can see the new data is classified as red. Now we'll discuss SVM algorithm. In SVM, input space is mapped to a feature space using some functions or kernels. Here we can see in the image that the data separation can be done by using a straight line. So as you can see on the left hand side in the input space, the separation is done using a curved line, which is very difficult to do. So by using SVM, we can like map the input space into a feature space, which has better class separation and which can be done using a straight line. So next algorithm is decision tree learning. So this is a learning algorithm, and it looks lot like a flow chart. So this is an example of a decision tree. So the internal nodes in a decision tree consists of tests, and branches are the outcome of those tests, and the leaves are the final label. So as you can see, in this case, the internal nodes are the tests which are being performed, and the branches are the outcomes, yes, no, high, low, etc. And the leaf nodes are the final outcomes, and these are the class which we want to classify. So this is an example for decision tree for buying a car. So initially we'll check if the car is road tested. If no, then we don't buy. Then we check mileage or car age. So you can follow these branches and come to a conclusion as to buy a car or not. And this is the final class label which has to be classified. Then running my application code. You can refer the README file for the steps which you have to perform to run my code for gender classification. And I will show you later in the project demonstration how this is done. So existing approaches. So I have like researched a lot on the internet for the existing research papers for gender classification, and these ones I think are very close and very related to the work which I'm doing over here. So the first one is agent gender classification can be done using convolutional neural networks, and the accuracy which they achieved was 86.8%, which is not that high. Then there's gender classification based on gait, which is how a person behaves, how a person walks. So the accuracy which they have attained is 97.9%, which is very good. And the next one is gender classification using LDP, which is local directional pattern. The accuracy which they have achieved is 95.05%. The last one is gender classification based on speech, and the accuracy is 98% and 95% for noisy speech. So this disadvantage based on speech would be you'll have to speak very close to the mic. So this is the result when you run my code. So these are the confusion matrices, 5 for each of the classification algorithm. First, I'll discuss LDA. So for male, I have checked for 40 males, and the actual label was like for prediction was done correctly for all the 40 males, and there was no wrong prediction as you can see over here. For females, there was one wrong classified as a male. So for LDA, there was in all one wrong classification. For KNN, all the male classifications were correct, and for females, there were two wrong classifications. For SVM, all the classification of male were right. For females, there were three wrong classifications. For naive Bayes, all the 38 classification of men were right, and two were wrongly classified as females. And for female images, 34 were rightly classified as females, and 6 were wrongly classified as males. So you can see the classification for naive Bayes is not that good. And next is decision tree. So in this case, the classifications for male were 31 were correct and 9 were wrongly classified as females. And for females, 34 were right and 6 were wrongly classified as males. So in case of LDA, there was one wrong classification, KNN two wrong classifications, SVM three wrong classifications, naive Bayes 8 wrong classifications, and in case of decision tree, there were 15 wrong classifications, which is a lot. So this is the accuracy and misclassification rate for all the classifiers, and the formula for calculating the accuracy and misclassification is mentioned in my project report. So for LDA, the accuracy was very high, which was 98.75%. Even KNN and SVM had very high accuracy and a low misclassification rate. For naive Bayes and decision tree, the accuracy was not that good, especially for decision tree. The accuracy was very less. It was 81.25%. This table represents precision and specificity for all the 5 classification algorithms. So for LDA, KNN, and SVM, the precision was 1. For naive Bayes and decision tree, it was 0.95 and 0.775. Again, the formula for calculation is mentioned in my project report for precision and specificity, and it is mentioned in detail in the conclusion section of the project report. So this is the result section of my presentation, and here you can see the screenshot of my application. I have used the same image for men and male and female for all the classification algorithms so as to maintain a consistency in testing. So for, as you can see, for LDA and KNN, SVN, naive Bayes and decision tree, all the male and female images are being correctly classified. If you want to test for all the 40 images, then there are instructions mentioned in my code on how to comment some certain lines and how to uncomment certain lines so as to do both of these things. Future improvements. So in my project, gender classification works very accurately for images, and this project can also be extended for video stream. So the time taken to predict is not that small, so therefore the output of the streaming will have some delay. So this would be a thing to look for over there. So conclusions. So LDA, KNN and SVM have very good accuracy and therefore can be used for gender classification. In my project, LDA had the highest accuracy among all the classifiers. LDA had only one wrong classification, KNN had two wrong classifications, SVM had three wrong classifications. Therefore, they can be used accurately for gender classification. Naive Bayes had 8 wrong classification with the accuracy of 90%, and decision tree algorithm had 15 wrong classification with the accuracy of 81.25%. So both of these algorithms are not suited for gender classification. So project demonstration, I'll now show you how my project works. So I have done my code in MATLAB in 2016 version, and I have developed MATLAB scripts which can be shown on the left side. So you can see over here how to run my project, or you can refer to the README file. So I have deleted all the mat files because their size was very high. So initially, I'll start the female classified training.m file. So initially, I'll clear the console and all the variables on the left side. Then I'll read about 156 images from the female training gallery. Then I'll loop over these images, and initially I'll convert the image from RGB to gray, each and every image. Then I'll apply a Gaussian filter over these images. I'll then resize the image into 120 by 120 by using using a bicubic filter. Then here I'll extract the HOG filters, which will get the facial features, like I showed you in the presentation initially, how this looks like. So over here we can see the HOG filter being applied and all the features were extracted in this image. So I'll save all these features into this variable. So I'll just run the code over here. Yeah, so this is for female training. For male training, it is a similar code, but instead of the female gallery, I'm getting the images from the male gallery. So same thing, 156 images, each and every image I'm converting it to gray, then applying filters, extracting HOG features and saving them. So I'll run this. So this is done. So female and male features have been extracted. Then I'll concatenate both of these features into a single file. So you can see features have been combined. Now I'll set the labels for male and female. So for first 156 images, I'll classify them as male, and for other, I'll classify as female. Because in this case, first 156 images I have stored as male, and next 156 images as females. And here I'm setting the labels for them. So I'll run the code over here. Yeah, this is done. So now labels have been saved in this mat file, label save.mat. Now I'll perform the training for all the 5 classifiers. So over here I clear the console and the variables over here. Then I'll load the features combined, which are the HOG features and labels for those features. First I'll train the LDA classifier. So all the features which have been extracted, I'll train these classifiers using these features. So first I'll train LDA, KNN, naive Bayes, SVM and binary tree. So I'll save all these classifiers in these mat files, LDA, gender classification LDA, gender classification KNN. I'll just run the code and these mat files will appear on the left hand side. Yeah, so as you can see, these mat files are coming up. Currently the code is running. So this is the training stage of my application. Yeah, so on the left side you can see all the mat files are there. So now I'll perform the gender test, which will be the testing phase. So I'll load all the classifiers which I had trained earlier on over here. So I'll just read one file initially. I've mentioned total files to be one. You can just go through the comments in my code if you want to run for all 40 images and see the entire result. But I'll show you for one image only, one male image. So for one image, I'll do the same steps. I'll convert the image into gray. Then I'll apply Gaussian filter. And then I'll resize the image into 120 by 120. I'll extract the HOG features. Then I'll predict using the LDA classifier initially. So I'll just run this algorithm. So over here you can see it has been correctly predicted as a male using LDA classifier. If I want to do a female prediction, I'll just go and change this male into female and save the file. So if I run it, the new image will be classified correctly as a female. So here you can see a new image has been classified as female. So this is done for LDA. For KNN, I'll just go and I'll update the classifier over here. So instead of LDA, I'll write KNN. So if I run the code, it will use female image using a KNN classifier. So over here, if I update this to KNN, so now it will be correctly showing KNN. So KNN in female. And similarly, I can do it for naive Bayes, SVM, and decision tree. So over here, I'm just updating this information and checking. See, it is being correctly classified as a female. If I want to test again for a male image, I'll just change the location of the folder, and the next image which would be read from the test male folder would be a male image, and it is being correctly classified as a male. So if you would like to see the HOG features, I'll just uncomment the code below and I'll comment the 6 lines for testing these images. So let's see. Now I'll run the code. As you can see that I can easily see features of a male in this image using HOG feature extraction. Yeah, so basically these are the MATLAB script files which I've made for feature extraction and for gender classification using the 5 classifiers which I mentioned earlier, which are LDA, KNN, SVM, naive Bayes, and decision tree learning. And I have analyzed these classifiers in the final project report. The analysis is very detailed, and the conclusion which I came to was that LDA, KNN, and SVM classifiers are suited for gender classification. Naive Bayes and decision tree are not good classifiers for gender classification. So this was my project demonstration, and thank you for watching.